what is simple, shall I say, properties of metal? Ductile means that it can be expanded and turned into something solid, into wires and whatnot. Malleable means that it can be hammered into solid form, into a sheet form. If you see the old time, last time, I remember my town, in Penang, small town, there's a metal smith near my town, where they have a furnace there. They take solid metal, they want to create, say, like a knife or parang, whatever it is. They just burn the metal in the furnace, and then they start to pound, to hammer the metal in its red situation when the metal is still hot and ready. They start pounding one after the other, then it become flat, become like a knife. So we don't see that kind of activity anymore. And then they, of course, good conductor of electricity, especially copper. Copper is why you see most of the copper wires. Most of the wires are made of copper. Insulated with some what they call this plastic material. Good conductor of heat. Yes, it can transfer heat very fast. Even the metal in sometimes in tower block or whatever high-rise building, there has a lot of metal kind of material built for the building. Sometimes they have to allow for some expansion because of the heat. The metal can actually expand. Shiny, of course, the luster shiny. Metal can be shiny. Depend on the kind of metal and the surface structure. Aluminium, what do you call this? Stainless steel, silver, are very shiny. Copper, lead, and shiny. High melting point and boiling point. Of course, at normal temperature of heating, like we used to cook, kind of higher is no way they can melt. It has to go to very, very high. It can be up to even, I mentioned 1,200. I think I saw 1,800 for those high density metal. We'll go through until what they call high density, high carbon metal, high carbon steel, call it. Density, yes, is very compact. That's why it's very heavy. Strength, it has all the strength, depend on nature of the steel again. If it is low carbon, the mine steel that we used to do is very strong. High carbon, even medium carbon steel is even stronger. Then the high carbon steel even strongest. Then we can I'll show you after some example what do you mean by all these type of steel, the low carbon steel, medium carbon steel, and also high carbon steel. Of course, is the product of going through a process of heating and through the furnace, and then they come up with so many products that can be used in our building industry. And then you can build a simple structure like this by having the universal beam and column, they call it. I will know about it later on what you mean by universal beam and column. And then we can turn into this kind of simple building, built of metal. And it's very fast construction, has all the advantage over the concrete. All right. Okay, let's see a bit of history. I mentioned about history. Maybe it's a bit too far. Mesolithic, basically, during the Stone Age. Hunting, gathering communities move across land near the British Isles, forming stone tools. Monolith, small thin blades mounted in different combination to make a variety of tools. Basically, in the early days, this is Stone Age, they use stone to make it sharp so that it can become a tool for cutting purpose. 2000 BC, the gold also they found in Stone Age. Men learned the fashion into gold jewelry. You see all these Egyptian kings. The popularity of gold is largely due to the scarcity, value, and mankind fascination with metal. See the face of Tutankhamen here. All is built of metal, of gold. And then come to this is some of the tools they use during the Stone Age. Look at how they tie the tools, the stone to the stick, so that they can use something like a hammer kind of thing, or something like chopping, and they can chop many things. Those are the tools they use. And then for the gold, for example, it was first found in gold nuggets. It's just something what you see below there, nugget, discovered in 2000 BC. People first used gold for money, and they often sold it to people. So gold was appreciated a long time ago. Even in Quran, I mentioned to you, it's already there. And then in 4000 BC, silver. Silver, basically, silver spoon. hard, but it's widely used throughout history as a basis for monetary system. They use as a money, as a coin, and played central roles in the currency of Roman and Chinese empires. And then the 3500 BC, you got copper. Copper is 4200 BC. Use copper and as its integrity is of more significant than gold, as the first tool, implement and weapons were made from copper. These are raw material. There's raw material. And we'll talk to you later on about some alloy material after. You got lead. Lead also, we don't use so much in the building, but you're talking about back in 9,000 years ago, the oldest known artifact of lead is statue found in Temple of Oasis on site of the. This is something about history. So the wheel is used in Central Europe. Wheel, lead and lead wheel. Bronze, another famous Bronze Age, they call it. It began when the metallurgists discovered mining two metals together created a stronger substance than either of the individual metals. This is a mix together. This is they call it alloy metal, non-ferrous alloy metal. Okay, this is you got to mix, I think, tin with something. I think we got it in our next the future, what you call this slide. That is silver. Yeah, it's always shining. Silver conduct electricity very well. Silver and copper conduct electricity very well. Maybe harder than gold, but it's very ductile. Ductile, it can be expanded, can be pulled, can extend into cable, from solid to cable. Malleable, it can be hammered into pieces, into small sheet, Silver is only used as jewelry, dental alloy, silverware, and photography. Why bronze important in ancient time? Bronze marked the first time humans started to work with metal. Okay, bronze tool, weapon, stone replaced earlier stone version. Human made many technological advances during the Bronze Age, including the first writing system and invention of the wheel. It's a bit of history. I not very sure. I was not taught even about this kind of history. Just maybe for the sake of having this class, I learned something also here. What was lead used in the ancient time? For the ancient time, lead touched many areas of Roman life. It made up pipes, dishes, cosmetic, coin, bullet, paint. Eventually, as a host of mysterious maladies. Maladies is something to do with disease with the animal. Animal disease became more common. So some Romans began to suspect a connection between metal and this illness. So they believe that way. So come to 1500 BC, they got iron smelted. Before that, it's a tin. Tin is found in 1750 BC, first smelted in combination with copper. Tin also, I think it's alloy, yeah? No. Bronze, brass, and lead is an alloy. Tin is natural. Smelted with copper around 2100 BC and produced bronze. Yes, it's alloy. Bronze is made of tin and copper. Okay, then Olympic at that time 700. Then iron, basically discovery of metal around 3000 BC led to the start of the Iron Age, around 12,000 BC. And the prominent use of iron for tools and weapons. Of course, initially people are fighting each other. They're talking about survival. They go for food and they go to defend themselves or they attack people. So that is the nature of this ancient time. The Hittites discovered iron 15,000 BC, giving them extreme advantage in the war. This is where they start the war. This is Pompeii was started at 29 BC. And then the first recorded windmill, 1185, the year 1185. And then there are some other, there's a lot of material we mentioned here, but we are not so much interested in those that so much they're dealing with our building construction. Basically, how was tin used in ancient time? Tin was found to be the most effective vessel, some container, store combined liquid and dye while they involved with that. This is something to do with dye. I don't know, they use for something, I'm not very sure, for clothing or whatever. Tin was also an important product for use in solders. The soldering material. Soldering to where you hit the call this the metal pointer, and then it is a jointing from two material. Mixing of tin and lead to make the melts easier. Solder were used in a sort of craft, including jewelry, metal, pottery, and tool. Wait, the screen is not moving. Okay. During the Iron Age, people across much of the Europe, Asia, and part of Africa began making tools and weapons from iron and steel. So the use of iron became more widespread after people learned how to make steel, much harder than metal by heating iron with carbon. That's what the basic content of steel basically is iron and carbon. All right. And then come to 1700, the invention of steam engine. They found cobalt, antimony as a kind of material that I never heard of that before because I'm not metallurgist. Then discover metal in the 18th century, like bismuth. Bismuth is something to do with main uses is pharmaceutical, atomic fire alarm and sprinkler system. I mean for nowadays, not during ancient time. And then solders also and other alloys, pigment or cosmetic, glass and ceramic, also used as a catalyst in rubber production. That is the form of bismuth. Of course, the manganese, molybdenum, titanium, also all sort of name of it. Tungsten is another that we use also in our building industry. Currently used as electrode, heating element and field emitters, and as a filament in light bulbs, in the light bulb, and then cathode ray. Tungsten is also commonly used in heavy metal alloys such as high speed steel. Actually, high carbon steel is the same meaning. High carbon means very tough, very hard, used as drilling tools or kind of thing. We show you after that. And then from which cutting tools are manufactured and also used in so-called super alloy to form wearing resistant coating. So there is tungsten. Tungsten, it's not so much not such a kind of steel, but it's more used for like bulbs and kind of thing. Titanium, yes, titanium is in 1791. They found titanium. Also discovered in the 18th century. It wasn't until the 1940 that titanium was used in structures due to impurity because of the density. Titanium basically metal is very durable for engineering application because this metal is corrosion resistant. Corrosion resistant like stainless steel, titanium. Also, this metal is very strong, very light. It is 40% lighter than steel, but has a strong high strength steel. So lithium find its application in titanium, find application in things like aerospace, building facade. Even nowadays in Europe, in US, they're using this as building facade. I mean, together with aluminium and stainless steel, can use building facade. This is for aerospace. Most of the aerospace parts are using titanium. I remember one of my architect understudy when I was doing my master program, MPhil program in Sheffield, is Ian Ritchie. Ian Ritchie is very, shall I say, modernist, and yet he loved arts. He loved arts. He looked for high technology guy. I mean, things like when he said, when I went to see the aerospace show, I didn't see the plane flying, but I see the detail of titanium being fixed to the plane. Even titanium from the tire, the parts of the titanium, it goes up to the building. So he had to see this kind of thing. Ian Ritchie. Then you got chromium. This is another building facade by Frank Gehry. I think this is a Disney Museum. Even Guggenheim Museum in Balboa also use the same material. It's light and of course it lasts, and it's expensive, of course, very expensive. Uranium basically it is not so much of we tak pakai. Kalau kita dengar uranium, we think of bomb kan. Okay, this is 1790 yttrium, 1797 beryllium. You can find out yourself about all this material. 1799 Napoleon come to power. And then we have this silicon. Silicon, interesting, right? Silicon, basically, the element is a major concern in ceramic and brick. Being a semiconductor, element is put into use for making transistors. Silicon is widely used in computer chip and solar cells. Yeah? Yes, solar cell is a vital component of modern cement. Silicon also used in production of brick, production of fire brick. We never seen this kind of thing here in Malaysia. I don't think so. We have this. Silicon is quite expensive. At the same time, the silicon is famous for sealant, as a sealant, you know. And this is what we call sealant. They have even structural silicon where they seal, they join glass together, no? For a high glass kind of panel, maybe 6 meters and above. They use this. They call it structural silicon. This is very, very strong. Most of these, again, wall panel like aluminium composite panel, and some of those stainless steel panels. Sometimes for the external wall, they also use silicon to seal all the joints. Aluminium at the same time, another very famous, shall I say, material for building construction, but not for structure, but more for finishes. Finishes, even some like structure like railing, those kinds can be used. So is aluminum metal? Yes. Aluminum is silvery white, lightweight metal. It's soft and malleable, soft and can be shaped. Aluminum is used in huge variety of products, including can, foils, kitchen utensils, window frames, aeroplane parts, and so on. So that time maybe on the in the early years they use as a plain parts for because it is light, very light. So the frame you can see that it's made out of aluminum. And then we got aluminum, got silicon, as mentioned that is gone. And then come to the 80s, we got helium, gallium, all these kind of things, polonium, radium. So you got to find out what's all this yourself. This is sometimes it's something like a chemical form, tapi it becomes crystallized. And then europium, macam opium, lithium. This one you become metallurgist, but you know all this lah. The helium, all this kind of names is alien to me. Alien to me. Only know the basic kind of steel that we use for construction. All right. Okay. Now let's go into the real understand of metals. Basically, there are two main group of metal. You can categorize in the two main group. Okay. One they call it ferrous, the other one non-ferrous. I tell you what you mean by ferrous and non-ferrous afterward. And then for under ferrous is all metal that consists iron. They got split into two. Basically, they got pure ferrous metal like iron, that's pure, and then another one is ferrous alloy. That is steel, which is combined with carbon, cast iron, stainless steel. High-speed steel is the same as steel. It's one of the category of steel. That is high-carbon steel. All right. Then for the non-ferrous, that is without metal. Without metal, it's not magnetic. If it is ferrous, I mean that you can respond to magnetic pull. Non-ferrous is without magnetic pull. Basically, they have pure non-ferrous metal and then non-ferrous alloy. Alloy basically is a mixture of two chemicals, two metals. Okay, what is under the pure non-ferrous? Basically copper, let me say copper, aluminium, zinc, tin, lead, silver, gold, and mercury. Mercury is actually liquid at room temperature, but it is considered as it's categorized as a metal. And then the alloy basically is brass. Brass is basically is combination alloy of copper and zinc. Then got bronze, is a combination of copper and tin, and then solder. Solder is for drilling for jointing of two materials together. It's an alloy of lead and tin. Okay, based on this one, we'll go through each of this one. See what is the so-called how they were formed, and then what are the uses of this material. Okay, ferrous metal. What do you mean by ferrous metal? Ferrous metal are metal that consists mostly of iron. So a small amount of other element. Ferrous metal are prone to rusting if exposed to moisture. That's one thing. What is the advantage of ferrous metal? Like my steel, all the steel are rusty, unless you put some coating, some treatment. Ferrous metal can also be picked up by magnet. They are attracted by magnet. The rusting and magnetic properties in ferrous metal are both down due to the iron, because the iron ore. Iron content is very high, so that is caused the corrosion. And then typical ferrous metal include mild steel, cast iron, steel, high carbon, high speed, same high carbon stainless steel. You can see those the rust condition, and it's all. I mean, this is the characteristic of actually attracted by the magnetic. Ferrous, non-ferrous is without the attraction of magnetic. Just simple as that. Okay, what is iron then? So similar malleable ductile magnetic heavy metallic element that readily rust in moisture air, occurs in pure form in meteorite just like what you see here in the photograph here, and combined with more engineered rock is the most abundant element on Earth by mass. So they got a lot of this iron on the Earth's crust, in the Earth's crust. Ductile, it can be, as mentioned, it can be expanded into wires, or it can be, and then malleable, it can be shaped by hammering. Okay, where is iron most commonly found? So iron is most abundant element by mass in the Earth's crust. Then the core of the Earth is thought to be largely composed of iron with nickel and sulfur. The most common iron-containing ore is hematite. It's called hematite, but iron is found widely distributed in other materials such as magnetite and also taconite. These are all the form the combination of iron. So if you're talking about Earth layer, there are so much of iron, so abundant because it is so big and so huge. So look at the Earth's crust. It's just a line below the Earth, just the first layer of the Earth or second layer of the Earth. That's where most of the iron is found. Like some of the photograph, like you see here, these are layers as they cut the hills, layers of iron. This is after the iron being excavated, and they gather here probably to be transported. These are some of those most of the ores, the original kind of material that we found. A rock containing enough. Most metal are found in compounds in the Earth's crust. This is the kind of shape they found. And then a rock containing enough of the metal for extraction to be footable is called an ore. Of course, simple rock maybe cannot be used unless you go deep into the earth. Then you find some what they call this commercial value metals, material that can be used for whatever purposes. Even we're talking about bauxite. Bauxite last time there was some what they call this issues on bauxite in Kuantan. Excavation of bauxite in Kuantan by this Australian company. They red, the whole town, the roads and the cars and the houses all become red. But that bauxite is for the use of the aluminium, manufacture of aluminium. What else? Where is iron found? Iron is found everywhere. Okay. Iron is one of the most common metal in Earth's crust. It can be found almost everywhere, combined with many other elements in the form of ore. Okay. So you can see iron. Maybe you can try to dig behind your house, you can find iron. But depending on the nature of the earth. But you got to go inside maybe 100 meters in. Okay, let's see what is cast iron. Cast iron basically is very strong metal when it is in compression, and it's very brittle. Brittle, it can break, rapuh, brittle. It consumes 9% iron and 4% carbon plus other element. Cast iron be used for basically kalau we are going to look at some of these images here, use as car brake, disc car cylinder, metal visors, manhole covers, machinery based the drill pillar or whatnot. Manhole covers, so you said that why did they need such a very strong material? Because cars, lorries, or very heavy vehicle pass over these manhole covers sometimes, so they have to be very strong. Okay, so basically this is what they call this cast iron. What do you use for building then? So cast is not good for structural material, of course, because it's brittle. The properties of brittle, then it cannot be. So they cast probably for basically for facade treatment, for element, decorative elements, whatnot. So It's not good for some material for handling tension and bending moment because of brittleness and relatively low tensile strength. So compared to steel and wrought iron, it has coarse crystalline structure. Melting point is very low. So that's its weak strength. So it is only used for casting purposes. The cast and the paste as a decorative purpose. That is also used in architectural drawing, especially in Europe. There are a lot of discussed iron element on the facade of the building. Um, Even the use for services purposes for pipe can still be used. Any for pipe, the what you call this for Swiss valve. You see in front of big building, you have this Swiss valve where the main water meter is fixed to this the last photograph here. And then for gates, for gate and fencing, decorative gate and fencing, this is mostly found in Europe, but we still have here some cast iron gates. As you go something like Istana, when you come to Shah Alam Mosque, I think the gate is made of cast iron. Shah Alam Mosque fencing. Yeah.
Sir, I just have a question. Casting meaning like a facade finish, like.
Yeah, cast mean here that it is in raw material, in liquid form. They cast into a form, they have a mold, some decorative mold, and then they cast and then they let it dry, they become hardened. But it's not structure, they just fix on only. Like you casting a concrete, you got a formwork, formwork where you got a reinforcement, you put concrete, and then take out formwork, it become a beam or column, right? Something like that. But this time, they cast in a loose form so they can be fixed anywhere in the building that they are talking about treatment to the facade of the building. But now into modern days, modern architecture, you don't have any more of this. But for classical architecture, Baroque, Renaissance, you can see a lot of this kind of element on the facade of churches and whatnot. Okay, now steel. This is our the main shall I say material is our focus on steel for this subject for this semester. Just give you some overview of those related steel, related material that related to steel. Okay, basically I mentioned to you earlier on that steel has been categorized into three types. They have a low carbon steel, medium carbon steel, high carbon steel. What do you mean by this? Because steel is a combination of iron and carbon. But did you know that there are more than 3,500 different grades of steel? So steel grade is determined by amount of carbon, what the alloy is contained, and the way it's been pre-processed. The more you have the carbon, the higher they have the carbon, the harder it becomes. Then it's become less ductile and maybe can be brittle too. Yeah. Okay. I put forward this kind of table to show you some of those content of carbon that be included in the iron, so that it become a different kind of character, right? It become a different kind of property. Basically, if you're talking about that mild steel, all this mild steel, with all percentage point something from 0.05 to 0.03, it basically are low carbon steel. These are low carbon steel, or the first category is the low carbon steel. Mild steel, low carbon steel. And then the second medium carbon steel is basically from 2.5 until 5. Okay, for mild steel, we look at the uses of the mild steel here. Mentioned here, the lower the mild steel, the lower strength it is, like sheet, strip of press work, car bodies, tin plate, wire, rod, tubing, kind of thing. And then sheet or strip press for press work, wire, rod, nail for the second mild steel. And then screw, concrete reinforcement bar, and then for a bit higher, what they call this percentage of carbon, you become a case carbonizing. I don't know what's it carbon. And then steel plate for the highest one. This is the one we use a lot. Steel plate section and for structural works. This is 0.1 to 0.3 carbon. They call it low carbon steel. This is the most common material used in building industry. The last one. Okay, the next one you call it medium carbon steel, which has got three shall I say division here, depend on the amount of the carbon, percentage of carbon in the iron. Drawn bar, shaft, high tensile tubing, shaft gear, railway tires. I show some of these images afterwards. Then the high carbon steel, basically, they have a lot of carbon there, but it's very tough, very hard So that they can become forging dies, railway rails, the rail railway, spring, hammer, saw, cylinder, lining, cold chisel, fogging die block, punches, shear blade, high tensile wire, all these detail, until ball bearing, drill, cutting, all the tools are made of this category of steel, high carbon steel. Basically, it can be summarized that within this 0.05 to 0.3 is called it carbon steel. This is the amount of steel, the orange color, the amount of steel. Then the iron is blue in color. And it's increased, it becomes medium carbon steel, then high carbon steel, the last one, the highest one. And then what is, now we go to detail of each of the steel. Mild steel. What do you mean mild steel? This I mentioned to you. We use this a lot in our building construction. See the first photograph here. All the frames are made of mild steel. This called it universal beam. Universal beam it comes in shape of T, U. This is the universal beam. H type. Okay, ductile and malleable metal. It can be extracted into wires or whatnot, but without changing the strength of the material. Malleable can be formed into from solid to sheet metal. So mild steel will rust quickly. Of course, it will rust quickly if it is in frequent contact with water. Even the moisture of that metal, if you didn't coat, you don't protect the mild steel surface, it will definitely rust very quickly. And then metal users use a stud, bolt, building girders. Girders is beam. In America, they call it girders. In Malaysia, we call it beam. The car bodies, gates, etc. Melting point is 1,600 Celsius until you hit this point, and then it can melt. This is where the scrap, all the scrap metal that have been collected from the what they call this recycle center, maybe. Then they burn it under furnace more than 1,600. Then it become liquid. Then it can form into whatever finished materials. That's my steel, low carbon steel. All right. For low carbon steel, this is some other example of the uses. I mentioned to you about what they call this the part the such element. The first photo here. As maybe this look like a column here. As a sheet, this malleability meaning that they can turn into sheet. As checkered plate, this two checkered plate is for floor. Floor sometimes put it for wall. This is to avoid slipperiness, so they create some texture and pattern. As a car frame, also can be used. And then it comes also in rolls, and tubing also, mild steel. Its property like ductility, weldability, malleability, mild steel make for ideal construction material for the steel building and bridges. Moreover, the mild steel complies with stringent systemic and wind requirement, and it's also fireproof. Fireproof is not so much direct fireproof, but systemic, systemic wind requirement. I've done one project in Indonesia, apartment of 2 block 27, so 29, sorry, 2 blocks in Salemba, Jakarta. For 3 years, we up and down every 2 weeks in Jakarta. So we use steel, we use a lot of steel there, and then they use what they call this shear wall construction. That will take up the seismic. Seismic means the earthquake. Also the wind will come in. This is some of the material used as a building material. Must use a building material. Frame structure for the roof and the structure for the building. Is the beam or the girders. They can join in many ways. We're talking about jointing when we come to the subject jointing later on. And it is a kind of reinforcement they use before they pour the concrete. We do all the checking, everything is okay, and then the engineer will give green light to pour the concrete. This is some of the materials used in a very creative way, like bridges. Can stand a long span structure, like the Sydney Bridge. Even a lot of bridges in Europe and US. In early days, not just bridges for pedestrian, cars, vehicle, but also for train, for railway bridge. This is some expression of how mild steel can be used in terms to create some emotion, movement in the form. Bridge with some kind of shall I say, flying feathers or whatever, and they're supported by cable. There are cables supporting the bridge. All right, and then another like a passage there. Okay, and then also we have some another creative kind of use of by steel, properly coated, properly protected, so it won't rust. Maybe yang the top one here is not my steel. Basically, this basically the main one is a concrete frame. I'm not very sure what the last one, but here below here is same by same architect. Kalau this is my steel. Okay, now is what is medium carbon? Okay, we have basically this is contain carbon, so that's a percentage, manganese from 0.6 and 1.65. And this steel are mainly used for making shaft, axle, gears, crankshaft, coupling, and forging. Basically for mechanical purposes, engine or whatnot. And then this is for forging equipment. Maybe tubing, tubing, yes. Medical services, medical services or whatnot. Railway, yes, railway tires, use this kind of steel, very hard. And this chain, used for whatever purposes. Okay, now it's high carbon. Ferrous metal, yes, ferrous metal, high carbon steel. High carbon basically is high speed steel, same thing. Okay, it is a very strong, very hard steel that has a very high resistance to absorb abrasion. Abrasion means geseran. It is two metal rub together, this abrasion. So up to 1.5% carbon content, very tough, used as hand tools, as a screwdrivers, hammer, chisel, saws, spring, and garden tools and whatnot. So what is considered high carbon steel or high speed steel? High carbon steel are those with carbon content, as mentioned just now, 0.15 to 1.4. About weight, the alloy is particular category constitute the strongest and the hardest within the three group, but they are also least ductile. That means it cannot be turned into, expand into wires or not. It's too hard, cannot be bent or that kind of thing. So these are kind of uses that we have gone through just now, especially for tools and whatnot. So what is properties of this high carbon steel? Basically, the granular means like grain, you combine together, it's very tough. It's more tough and elastic than my steel, more difficult to weld, so it's difficult to weld, so that we don't use in building construction such as a structural member. Can be magnetized permanently, of course, attracted by magnet permanently, can withstand shock and vibration. And the uses basically is to make part of the machinery, need hard, tough, and durable material. It's used for making tools for drilling and whatnot. This kind of machinery, or the machinery bawah tu, basically is made of this high carbon steel. Even the railway rail and ball bearing, chisel, these they have to be tougher than other metals in order to make it effective. Like this drill head, drill bits they call it. They have to be tougher than the metal, because sometimes you drill metal, go through it. If you go, I remember when we were doing the SDME, the Dubai project. I went to see this factory, this kind of fabricating all our metal parts. They use a big drill machine, that create big holes, like 1 inch diameter kind of thing, with a thickness of we have members all about 10 mm thick to 12 mm thick, so it's very heavy. So they use a machine to drill it. So I mean, it's not part of a machine, can do anything. So the next one is the stainless steel. Stainless steel to I mean, naturally when you see stainless steel, you see all around you, especially kitchen area, a kitchen utensil from your basin, all those medical kind of utensil equipment, from fork and spoon, anything that you need to be easily clean, kind of thing, it's not rusting. So that is the best. Is stainless steel. Kitchen sink, cutlery, teapot, cookware, physical instrument, and whatnot. So this is very common in for the daily use. But what about for the building? Okay, another one about this. The best thing about the stainless steel that is corrosion resistant. Corrosion resistant. Chromium is part of the material, the alloy, that element in part stainless steel, their corrosion resistance. They use the combined with chromium, about what 18%, you know, that, yeah. Fire and heat resistance, especially high chromium and nickel alloy grades resist scaling and retain high strength, high temperature. So it is not so much of structure, but more for maintenance free kind of material, for building purposes. Stainless steel is durable, affordable metal that is used for a wide variety of purposes, strong, making perfect for construction purposes, and corrosion resistant, so it can last a long time without being replaced or breaking. Let's see what are the some of the most popular used stainless steel in construction are architectural cladding. You know this aluminum cladding. They call it aluminum composite panel. Handrails, that is quite common. Handrails, drainage and water system, wall support product. These are all jointing, screws, frames, roofing, structure. But we seldom structure. Yes, structure not that much. We seldom use structure. Facing some detail of fittings. We use aluminum. This is common side of using aluminum, especially when you have a heavy traffic where you're around the lift core, lift lift lobby. So people touch the wall all the time, people scrape the wall, so it can stand for discussions or whatnot. That's why even in the lift lobby, lift car itself, the finishes is basically most of the finishes are made of aluminum, even some stainless steel. Railing is very common, aluminum. It is non structure, just fixed to the floor. It's all the safety balustrade and whatnot there. And then comply to the fire requirement, comply to bylaws and whatnot there. And then one thing that that make this this stainless steel, that make the stainless steel, that make the what you call this stainless steel as one of the external finishes, is found in our Petronas Twin Tower. The Petronas Tower is the finishes, the skin, all made of stainless steel. Very expensive material, but it glitters at night when it shines, and again it is sort of easily maintained. They have the what they call this, the maintenance what they call schedule that goes around. They got the what they call this maintenance machine up there. They go around the machine. They from top to bottom they can clean up easily without having much effort to scrape or not. Maybe probably washing is good enough. But of course this is expensive. There's another one building that uses stainless steel. OUB Bank in Jalan Raja Lot some second, but they use it for the frame. All the frame is stainless steel. It's not aluminum. It's not aluminum. It's not my steel. So it is stainless steel. So again, they are talking about free maintenance kind of thing, or less maintenance that matter. Okay, for the other uses of stainless steel, basically for those heavy equipment that need cleanliness, even your kitchen equipment, commercial kitchen equipment, talk about commercial hotels, restaurant, big restaurant, banquet hall, lab kind of thing, and then your gate, your hinges are made mostly of stainless steel and brass, your trolley, your handle, and then some of the fitting, stainless pipe fitting, flanges, or the joints, members, or parts of the fitting, piping fitting, even rack, whatever it is made stainless steel. Tubing, even now you can see this stainless steel water tank protrude out on the roof. This is common sight when I went to Korea at one time last time. I see this a lot on the roof. Wow, that was back in 1988. We didn't see this in Malaysia actually, but now we can see a lot in Malaysia. The external, but in our case, because the external is very hot, when it put under the sun, the heat probably can get good hot water for a day, and there's a boiler. So even in normal day, our tank, our poly tank, which is made of rubber, if it's under very intense heat, like 32, 33 kind of Celsius, even the water in the tank also is very hot. But not mentioned about stainless steel water tank. Probably it is too hot for you to even take a bath. Even some element of steel being used as a gutter, part of the house. Okay, the piping or not. Okay, next one is non-ferrous metal. What is non-ferrous metal? Their metal do not have any iron in them. In them. No iron at all. This means that non-ferrous metal are not attracted to a magnet, and they also do not rust in the same way when exposed to moisture. Typical non-ferrous metal include copper, aluminium, zinc, tin, lead, silver, gold, and magnesium. So basically, we are talking about when there is no iron content in the material, in the what they call this metal, then it's not subject to rusty or corrosion. So these are the other category of the metals that also can be used for in building construction. Okay. Basically, this is in the raw form. Sometimes it's not so much raw form. Sorry, some being shaped already into the form. You can see the differentiate by the color. By the color. Sorry, this is sorry. By the colors and texture of the material. Let's see aluminium. Aluminium is another very common material used in building construction, similar to stainless steel. Okay, but it's less tough than less strength than the stainless steel, but it has a similar character, like it's not rusty, it can be shine, it can be washed easily, it can be exposed to weather, outside weather, and whatnot. So it tends to be light in color, and although it can be polished to a mirror-like appearance, it's very light in weight, and that's very light. That's why that aluminium. Now, aluminium is very commonly used in door and window frames. Door and window frames, even the high-rise tower, what they call this curtain wall. Curtain wall basically a wall that rise up from the bottom to the lower floor to up to the top floor, curtain wall, like one. You think curtain, I mean curtain, right from the top to the bottom. It's just no break, like that's what I think. So it looks a lot of this aluminum frame. And also sometimes use stainless steel. The cost is cheaper, it's cheaper than stainless steel. Okay, basically they use for cooking foil. This is for daily use in a household kind of thing, cooking foil, window frame, leather, expensive. Expensive bicycle is okay, normal bicycle made of aluminum. It's very light. And melting point is quite low, very low. Unlike the mild steel, this kind of thing, it's very low. For building purposes, this question is aluminum metal, of course. Aluminum is most common metal found within the Earth's crust. I mean about 8% altogether, but it does not occur as a metal in its natural state. Because there's some other combination with in the aluminum, they call it bauxite. Mentioned the bauxite. Aluminum ore, they call it bauxite, must be first mined, then chemically refined. That means the process, you have to go through a certain process. So that being refined turns to the aluminum through, they call it one Bayer process. To this is the name of the process to produce the intermediate product like aluminum oxide. So there is certain process you got to take away other material first before it's being filtered into aluminum oxide. Called alumina. Now I think there's one big factory coming up, or is it being completed in Sarawak? One of the biggest in Asia, in some country, aluminium melting factory. It's widely used in building because its intrinsic properties, I mean the good qualities of lightness and corrosion resistance. Aluminium is used in external facade, roof, walls, windows, doors, staircases, railing, shelf, and other several applications. Again, because it has similar character as in stainless steel, except that stainless steel is more expensive. It's steel, but it's more expensive. If you look at this building, the component of aluminum being incorporated in the building include even the solar panel, frame, maybe the frame aluminum, chimney can be aluminum, roofing tile just can be aluminum. Curtain wall, the wall, curtain wall, this is too small curtain wall. Normally curtain wall will relate to high-rise building. Shading devices, just like your sun shading devices, mostly made of aluminum strip. It depends on the nature of the kind of devices, how it was designed. And then your garage door, aluminum sliding folding door kind of thing. roller shutter, they call it, roller shutter, that the door that roll up, and store it on top of your door, roller shutter, they call it. Balcony railing, window frame, window sill, those that exposed outside, that doesn't require, is protect from rusty. This is the best material to use. Shutters, fencing, yes, fence, even door, aluminum door, yes, fencing, maybe a bit expensive. Sometimes they use galvanized iron. That means they galvanize with zinc iron. They coated with zinc by electrified process. You can use that as fencing. Facade sheet, panel, cassette, gutters. All this can be used in a building. As far as aluminum as a building material is concerned. And then facade, I mentioned about facade. This is an example of aluminum composite panel that's used for facade treatment. You can see the building here. I mean, this is all pre-cut in the factory. They have a frame. Like for the second drawing here, the facade, they have a frame inside. They just click to the frame and screw up the frame. And the aluminum can be of many colors. This is very popular since 80s, I think in 90s. At first it get a bit expensive. Now things is competitive because last time there's only one supplier, they call it Alucobond. But now we've got many suppliers of aluminum composite panel. So the price has dropped quite substantially. Before it was, I mean, it's quite expensive. This is very high class building, expensive building. I mean, corporate building, maybe they use aluminum panel, composite panel. It says frame. Yes, there's a frame. This is, you see the frame holding the glass. This frame is made of aluminum. Of course, they call it aluminum extrusion. Extruded because there's some texture inside this frame that gives strength to the aluminum frame. Of course, some other accessories like stairs, step, ladder, whatever it is, also made of aluminum. That means that aluminum is widely used from kitchen utensil up to the facade of buildings. And then copper. Copper is one of the material that is look very expensive. It's nice looking kind of color to me because it's quite attracting in terms of color. Dark time, malleable metal, can be shaped. Often red or brown in color. Normally brown, bright brown in color. Very good conductor of heat and electricity. That's why that copper in building industry basically we use for wiring purposes. It remind me of I got this project before. This project is Pasar Keramat. Now they call it Keramat Mall. Project was really it's a market. It's a market. It's a market. Market is so much of problem in the market because I think they call Pasar Keramat. Also Keramat was lambat siap. It take about 12 years to complete. I was on the job for 12 years, and then we changed to many contractors. And then at one point of time when there's no contractor was terminated, the waiting time like I think about 1 year before they appoint a new contractor, before we do a new contract documentation. The building it was quite a big building. It was guarded by a company, security company, and then nobody knows what happened inside during when there's no activity. But apparently for 1 year, I think the guard or the security officer must be working together with this thief, actually cable thief or burglary, whatever they call it, thief. This thief, quite many of them, they strip every length of the wires inside the building. Every length of the wires inside the building. This almost all the wiring have been completed. The aircon has to put the electrical fitting also the up. Metal roller shutters, all the metal work they up, and they strip everything in the building. This is something we never believe. Nobody went to the site until one day the what they call this, the audit department, the government audit department, wanted to visit the site because of this they call it Project Sakit, the problem project. So every was surprised when you walk into the building, you're full of wires on the floor like small snakes. Wires that come from small wires to big wires, all around the corridor, all in the corridor, empty wires, all the copper inside the wires has been stripped off, and they sell the copper. Copper is expensive, okay? It's expensive. I remember I sold this copper pipe for my aircon for my office when I moved office. Can get quite quite expensive kind of product. So over there they spend, I don't know, every day for maybe for a year or maybe less than a year. They strip everything that has money, has a monetary value, from whatever metal, from aircon parts, from the lift motor. It's a real nightmare to everybody. So the copper is so expensive. I think when during bad time, even the thief, they even stole the manhole cover. Manhole cover mentioned just now on the road. So some cars may have dropped into the manhole because of this, because of the value of the steel at the time. Even see drain grating, they start to steal all this grating, drain cover. They sell it cheap. I mean, this is during bad time. Everybody got not many. I mean, this maybe most of them drug addicts, maybe. So this is a special case where I think they have someone in court for security. I think the security is working together with the thief. So I've yet to be called that many years ago, but yet to be called. I want a key witness there because I'm the architect for the project. Okay, anyway, coming back to this copper, chemical element, reddish assembly ductile. Called group 11. This is under you search Wikipedia, they will give you this kind of information of the periodic table that is usually good conductor for electricity and heat. Copper is found in free metallic state in nature. So it's a solid copper, except they keluarkan the called bauxite. Okay, what is made of copper? Commonly used to produce wide variety of products, including electrical wire, cooking pots, pan, pipe, tube, automobile radiators, and many others. Copper is also used as a pigment preservative for paper, paint, textile, and wood. So a lot of things can be used. This is the nature of color of copper. This is very bright, reddish brown. They can even use for, I think our 1 cent coin is made of copper. But now it's no more. It's not used anymore. For piping, aircon piping, refrigerant piping they call it, from your cooling tower, all those external unit of your aircon into your internal unit, your aircon diffuser. So all using copper pipe. Even hot water supply in hotels, hot water supply, all use copper pipe. If it's hotel like 30 story, imagine all the toilets having hot water, you'll be using copper pipe. A bit expensive, but it's the most. Copper also been used as a finishes to a building, but of course it's expensive. It's very rare. I don't think we can do it here in Malaysia. But the kind of color it gives sometimes kind of brightness, macam a bit luxury, not like gold, but it's a bit luxury in that sense. But it gives some nice texture to the building, and then the elegant look of the building by using this color copper. But in Malaysia, there's one building that has copper dome. Anybody can tell me that what kind of building is that? In Malaysia, there's one that I know of, and very brightly colored metal dome, like a dome, like a mini dome. Anybody? I'll give you a bit of clue. It is in KL.
Sultan Abdul Samad building?
Yes, you're right. Sultan Abdul Samad building. That is the copper dome, on top of the clock tower, and the staircase tower. So this copper dome actually is being it's been donated, I think, by Australian company. If I'm not mistaken, when they replaced it before, they were doing renovation to the building. So you can see the brightness of the color. It is you don't have to maintain it. Okay, what is zinc? This is another non-porous metal, zinc. When we talk about zinc, you know, we always remember of the ring roof back in kampong. Those who come from kampong area, maybe now it's not that common. Now it's a lot of metal roofing. During my years back in the 50s, of course we use atap roof first. Atap roof is nipah roof. We can buy from kampong folks. That is no problem. We can get it easily. But when the economy of the community is slightly better, maybe got a bit more money, then they use zinc. But zinc roof is very hot. Of course, you said, I don't think it's resistant to corrosion. It's mentioned resistant to corrosion from moisture. However, zinc is very weak metal and used mainly for coating steel. Screw pada juga lah some, used for bucket, etc. But it's more like material. But for a house, basically, if you talking about back in your kampung, they use this so-called zinc roof for the house. If you remember, this kind of roof, over the years it rust. Even in Kuala Lumpur at one time, you see all the shop houses along jalan area around Petaling Street, area around Central Market. It's all shop houses. Mostly the roof is made of zinc. So you can see very dark and unsightly kind of views from the top. Once you have a building that is higher than this building, these houses, these shop houses, then the so-called the views is quite unsightly. We look at this lower shop houses, so it's the kind of ring roof. They are all rusting. So this is the natural, the first kind of zinc that look very bright, shiny, but it's very hot. One thing about zinc, it gain heat very, very fast, but it get cold so very fast. Once the sun is off, then it's no more heat. So it doesn't retain the heat in the materials. Like some of the material, it retain. For even brick wall, for that matter, if your brick wall is facing west sun, if you have a room facing west sun and your room is covered with a concrete slab, the heat gain from the wall and the slab is so huge that even at night at 12 o'clock, you can still feel the heat come from the roof and the wall, because they retain the heat for so long. Unlike this metal, only when it's sunny, then it transmits heat. But once the sun is off, short while the heat is gone. That's one thing good about this material. Okay, what is zinc in metal? So lustrous bluish white metal found in group of this group of 11B. This is in the Wikipedia research. Periodic table is used principally in galvanizing iron. More than 50% of metallic zinc goes into galvanizing iron or steel, but it is also important in the preparation of certain alloys. So when you say galvanize, we will go to detail later on the galvanized iron and whatnot. We see the detail, but this is just to give you an idea. Galvanized means that a normal steel, my steel, they put in a chemical reaction kind of thing. They put a steel in the zinc inside there, and then they galvanize through electrolyzing. Then they become a coating. The steel have a coating. That coating, and the whole thing become galvanized steel. You can see this example like lamppost. The street lamppost, a lot basically is made of galvanized iron, so it is not rusty. Unless you cut the surface, you see the steel inside, and then the cut surface will rust. But not the external one. Railing, even the highway guardrail is made of galvanized steel. Sorry. Highway, the motorway, the plus highway, whatever, the guardrail, the middle guardrail is made of galvanized iron. So galvanized iron can be used for grating or whatnot. So that is where the content of zinc, about 50% of zinc being coated to the metal. All right. So is zinc used in building material or as building material? Zinc is abundant, lightweight and shiny metal, which has long been used in construction for roof and vertical cladding. It is perhaps most essentially used in Paris, where the majority of roof have been zinc since Napoleonic days, Napoleonic time. When I was reading this, actually I captured the photograph of Paris. When I was there in 1991, I went to Paris, go up the Eiffel Tower. We talk about Eiffel Tower as a steel structure later on in our future lectures. You see down below the city, all is white. Wow, I said Paris is white actually. Maybe this is one reason I said even the roof make of zinc and become white. Even the building also is white. So like very whitish kind of city. Not much of a landscape, but they have some very interesting architecture, exist kind of setting. The high rise and the low rise and whatnot. So to me, Paris is a city of arts, a lot of interesting architectural feature, which is arrived at looking at be designed not just as a building, but it's an artistic or sculptural kind of approach. So this building very interesting. When I was doing this master thesis on design process, when we asked the architect, Ian Ritchie, I remember I called Ian Ritchie again, he said in generating design ideas in Paris, in France for that matter, normally like what we do, we just think of, we got a brief, if it is like a big corporate company, of course we got a group of people sharing the ideas about design. One thing about them in France, they not just involve architect, client, engineers, but in Paris, in France, they call artists, they call mathematician, they call historian, they call, I can't remember the other 2 or 3 group in generating design ideas, not just architect. So all people is part of the so-called, the ideas that have been created in building or designing building in Paris, in France. So these some of the so-called zinc roof being used. Now they have probably modified some other alloys that make the zinc more less rust and maybe it's malleable, can be constructed easily. These some example, and maybe this is basically building is coated with galvanized iron sheet, which can be used as zinc as used as the basis for the galvanized iron sheet. So far, any question? Anybody? Do you understand?
Yes.
Faham you don't understand, just stop me. Because I'm give you this an overview, but we are not going to detail or this kind of thing. We just give you an overview, the kind of metals, and you know what is copper, what is silver, what is this material used for building construction, for facade treatment, for utensil. At least you know something there, but if you let them you design your building and then you put as a zinc roof, you be careful because in Malaysia they seldom use zinc roof. Kalau aluminium okay, aluminium panel, composite panel roofing can. Titanium yes, tapi only for very expensive building. Titanium, but basically using metal roofing lah, kita kata metal roofing saja metal roofing. Of course metal roofing again there are a lot of categories. We will discuss that on later on lah. Don't select something yang that is not commonly used in Malaysia. Some of the assessor, maybe you have portfolio review, they may not even exposed to this kind of material. They say that you must be crazy using this, this kind of thing. Try to get some common. But if you find something that interesting like titanium, you can give the reason why that you see titanium is the best material. Some of the titanium, like what we saw just now, the facade, they wanted to create something not shiny, some texture, some kind of rough time texture on the facade. That can be done for that kind of material. It depends on what you wanted to, what your design intention you. Okay, yes. Anybody want to add something? Tak dengar lah, sorry, I can't hear you lah. Very like the bergema, like echo. Maybe you have to close a bit to your speaker, to your microphone.
I'll connect my earphones.
Okay. Heba?
I used to.
Okay, any question? You wanted to ask something?
Yes, I want to ask something, but I want to connect to my earphones for the sound quality.
I can hear you. Anybody can repeat question? I can't hear you already. Sorry, it's like echo.
Not very clear.
Okay, never mind. You can write on the chat. We'll come back to that. So it's very low melting point for this tin. Okay, sorry, tin is basically ductile, very malleable, soft. Can be shaped, resistant to corrosion from moisture. Okay, this again similar to stainless steel and aluminium. Bright silver color appearance. Tin plate is steel, is a tin coating. Tin plate is steel with tin coating. Tin coating. Use coating as food can, beer can, beer can. Used in vessel, in this a small item. But for industry, building industries, I don't think we have that thing. So I want to show something about tin. Basically, at one time Malaysia is the main exporter of tin, world exporter of tin. Back in many years ago, I think I still remember they were doing the activity of tin mining. They use something like the quali kind of thing. They pour water and then they start to shake the quali, so that the tin will be dropped to the bottom and then all the soil will be thrown out. You see everywhere especially in Ipoh, Selangor, there are a lot of tin mining. This is like the traditional tin mining in Ceras and kind of thing. But you can see this activity of tin mining if you go to Tambun Timpak in Ipoh. This is the replay, reconnect, resurrect the tin mining activity. Certain time Tambun Timpak is in Ipoh. Can bring your brothers, sisters, or family for a weekend outing. Yes, quite a good place there. And then this is a Palong tin mining. You say that in Selangor, if you were to take a flight or maybe from your drone, you can see a lot of pools. They are all ex-mining pool. At the moment, there's one big project by Gamuda. I can't remember what's the name of the new housing scheme, the new township. Forgot. Near the Elite Highway that I used to pass by every day from my house Shah Alam to Nilai. There are a combination of used mining pool. They turn into a township. They make advantage of the pool to create some exclusive housing area that has the element of water, the forest, and the nature for that matter. So it is very, interesting kind of township. If you have a time, you can go and see. But the fact that they retain the pool, they take all the pools and then they just create housing and spaces in between the pool, including some nice landscape. This is tin mining in Malaysia. There's a lot they found in Ipoh and in Selangor. And then this is probably, I don't know whether you have seen this. When I went back to my kampung in Penang, using the old road from KL to Rawang to Serenda to Tanjung Malim, to Ipoh, you can see a few of these drain. Dredge, they call tin dredge. Tin dredge is like a ship, a ship where they actually lower down the dredge, they scoop the earth in the earth, and then they filter the earth with the water, and then you really take the tin and they throw back all the earth into the water. Tin dredge is very common sight in the 60s. Now, I don't see anymore in Selangor. I think there's one in Ipoh, Sri Skandar, from second, because my friend architect is doing some kind of a museum to the existing dredge. They're getting some kind of a showroom for the township. They retain the so-called dredge. They turn into a museum, which is quite interesting. Tin is one of those main common material that is very valuable to Malaysia at the time. This open pit mine is also found in Malaysia. I didn't manage to get a photo of this. If you know this area Sungai Besi, anybody pass by Sungai Besi, near the toll house. You can see on the left there is a new, shall I say, hotel called something Golden Houses, Palace of Golden Houses, and a shopping complex, and then the two very big pool there. So those pool originally is this open pit mine, something like this, the top there. And then with the developer, they come up with some idea. They buy the land and then they turn it into a pool. They bring in water. I don't know how they bring the water, such a big area. Maybe they, divert the rainwater. Then slowly it fill up the pool. It become a big lake, a big lake. So it become very exclusive kind of site there, near mines and golf area, Mount Golf Resort, Palace of Golden Houses. This is the use of the ex-mining pool. So again, I mean, talking about the use of tin may not be that much in building, but more on your daily kind of usage. But talking about tin as a material that support the economy of Malaysia, this is where it come from. But nowadays, I don't think there's much activity on tin mining. Maybe they still have some in Terengganu. Terengganu is gold, is it? I can't remember. But anyway, I think there's not much talk about this tin mining in Malaysia. Yeah. Last time we export raw in what they call it, Jongkong, they call Melayu in Jongkong. So, but now they can process all the Jongkong, the raw tin into some other product. Okay, I think we are coming to an end. We have lead. This another material. It's not much used in the building material, but it is important for you to know. So, basically, it's a very soft, malleable metal. Can be shaped. Can be shaped. Also counted as one of the heavy metal, something like mercury as well, heavy metal. Lead has a bluish white color after being freshly cut, but soon tarnished to a dull grayish color when exposed to air. You can see some example here. The flashing, I think lead is not much used here. And flashing, we use a lot of this GI, galvanized iron flashing. This is in Europe, in England and UK maybe. They use lead that that cover the edge of the so-called the wall and the roof. They call it flashing. And then for roof flashing, also used for batteries, X-ray protection. That is also used for east west in many ways. So the melting point is very low. You can see the car tire for balancing. Those who used to go to balance your tire, maybe you follow your dad to balance your tire, they attach a lead kind of piece at the edge of the rim, so that the tire is in balance. So it's not like shaky kind of thing. So they use that lead. It's quite soft actually. Use of lead in other industry, in industry basically, building construction material, plumbing, paint, other uses like you see this now. This is for flashing in battery, and the internal part is made of lead oxide. And then some pipe jointing, the head, the pipe found in old homes. The middle one, not the pipe itself. I think is a brass. The middle one, is a jointing. It's made of lead. Quite soft actually, lead. And then silver. Silver also is not so much of use in building industry. Much more for again sometimes for cutlery. What mentioned here is used for trophies. Even mirror, made of silver. Your surface, the reflective surface of the mirror. Is made of silver. Okay, soft white lustrous, transistor metal, highest electrical conductivity. It's very good for electrical conductivity. For any element in the highest thermal conductivity of any metal. The metal occurs naturally in this pure free form. It's pure form. The brass. What do we use for? Okay, gold basically this is more for jewelry. It's expensive material. So used in computers and conductors. Also for the reflective power for protect satellite. The slide one used in satellite. Protective power to protect satellite. So it's dense, very soft, shiny, malleable, ductile metal. Pure gold has a bright yellow color. Luster traditionally considered attractive. The color that attracts, that's quite attractive. And then maintain is oxidizing in air or water. Gold receives attacks by individual acid. So there doesn't affect. If you throw any acid, so it won't tarnish. Discolor, crumble, or doesn't affect any more solvent. So this is why that gold is important. It is very strong even it's being submerged in whatever acid. So how gold is seen in a building connection with building construction? Is this a gold that it is real gold? You know, it's a big like a mountain full of. I was in this place back in I was visiting Burma, Myanmar, Rangoon. When I was this one job that we were looking at was an abundant job. It's a fair barter trade kind of deal with my client, and my client is corporate man here, and we're very close with Burmese government. We got a very good piece of land, like the Golden Triangle of KL. So one architect, Malaysian architect, was doing the job. Halfway was abandoned when all the footing had been buried under the ground, had been piled, or piling. It's a big complex. It's like $200 million project. I mean, that was back in 1990. It was quite high, quite expensive. So we went there for a visit because we want to revive the project, but it never happened because there are a lot of shall I say misoperating of a lot of things. Thing was not done seriously. I think there's a lot of cheating there. So anyway, I called off. I went there for a visit. I did some proposal. I said no. So I went to this so-called temple. It's very brightly lights at night, and it's very prominent in the city of Rangoon, Myanmar. Sekarang panggil apa? Rangoon is the old city of Myanmar, the capital of Myanmar. I don't know whether it's coated with gold or not, but looking at this, it is real gold. Do you know? So I don't know if it is real gold. This is fantastic, right? But gold is also found in China, for example. This is a real gold, channel leaf metallic powder coating, water based on real gold. So basically, I mean, gold is not so much a structure, nothing much on the building unless it's so. The guy or the client got so much money to throw, he got tons of gold maybe, so we can do something to brighten up the building. And even kalau you're talking about some interiors in Dubai's hotel, this is Dubai hotels, which is I was reading through the articles. There is some made of gold. The finishes, the interior made of gold. Even if you go to not Burj Khalifa, the hotel floating by the side of the sea, what do you call it? That one, if you go one room rental is like 1,000 or 2,000 US. Most of the fittings, the bathtub, the pipe, everything made of gold. But it's more for the eye to see, but not for the use of construction. It's more for the people got so much money to throw. So to them, probably this is the best thing they can do, but not to us. So basically, we are looking now at the alloys. At the last few slides, alloys is mixture of two materials. So what is brass? Brass is actually made of copper. This is no iron, non-ferrous alloy. No iron at all. No magnetic pole, and doesn't attach to any magnet. So brass is actually made of copper and zinc. Bronze is copper plus tin. Soldering is a jointing of two materials together, made of lead and tin. Okay, so non-ferrous alloy are metals that are a mixture of two or more metals. So the main one in everyday use, these are the three, which I think brass and bronze is used in building, and also solder. Okay, so basically brass is a mixture of copper and zinc. Maintain its main component. Its brass is usually classified as copper alloy, copper alloy. The color of brass varies from dark reddish, bright to slightly silvery yellow. Brass stronger and harder than copper, but not as strong as steel. Okay, it is easy to form into various shapes, good conductor of heat, and generally resist the corrosion from salt water, even salt water. So if you want to retain your holiday house in near the sea, then you could probably use brass element, coating the frame and the roof, maybe. So basically, kalau you see this brass, we talk about brass band, that's like a brass band. I think because most of the instrument, this consumer probably made of brass. You can see some of this instrument. So used as water fitting, screws, radiators, medical instrument, cartridge setting, firearm, even firearm made of brass. Again, commonly used in application where corrosion resistance is low, friction is required, low friction is required. That means not much vibration, such as lock, hinges, gears, bearing, ammunition, casing, zippers. Your zippers, you can see the color is made of brass. Plumbing, hose coupling, valve, electrical plug and socket, also made of brass. Things like this, you can see some of the jointing of the pipe is brass. It looks a bit of gold, but not like gold. It's not as shiny as gold. Yes, this one is actually on ironmongery. The lot of expensive ironmongery made of brass. I remember choosing the lot. I was doing some project in Sana, Kelantan for Rulers Conference Hall back in 1988. No, 84. We was selecting all this collection from UK on the brass product for the building, for the building. And of course, it's expensive. Another thing about brass that we use in building, it basically become a separator. They call it dividing strip. And this eventually, sometimes if you use a different material, chain of material, you can divide it with brass. A brass strip, we call it. Sometimes you want to break the so-called construction joint. If you remember, I don't know whether you come across, they call this, I forgot about the name. This is basically used where you want to create to reduce construction joint for cracking. You put a brass strip to break the expansion joint. So, and sometimes they use as a creation, so they create some pattern on the floor by having this brass strip, they call it, brass strip. Like what the photograph where you have this one, the marble strip, plus the marble slab, plus the brass strip in between. Can't recall this material again. They use some material. When you lay over a large space, large area, and then after a while, due to exposed to rain and sun, then you get cracks. A lot of cracks. It happens cracks. So to avoid this crack, you have a lot of this metal. They call it dividing strip to break the movement of the surface. That will be protected. Then you look better. Okay, the brass strip. This can use for architectural finishes, and this plum basically for. What's the use of plum? Anybody? Anybody can answer this? It can be made of the lead, brass, So basically, this pointed kind of shape is for you to get the straight vertical line from top to bottom. You want to do construction, you want to without any kind of like latest machine, latest equipment like pakai sonar or ray, whatever, to get the straightness. Then you use this plum. It's very heavy, tied to a string, and then you tie to the top and then touch the bottom, so that is the straight line. So you want to check whether the wall is straight or not, you just put this string on top and then see whether the wall is straight or not. This is used for construction too, as a equipment to assist in the construction of walls or not. Okay, and then bronze basically is an alloy of copper and tin. Primary copper usually is with tin as the main additive. It's hard and brittle, can be break. It has a very high resistance to corrosion. This is why that you can use for ship propeller because it is basically touching with salt water. So that is the most probably the practical material used for a ship propeller. Underwater fitting, anything that is in the water, also used for statue, medal, and whatnot, medallion and whatnot. And the bell here, so one probably for ceremonial purposes. Also made of brass. Kalau uses of building material, bronze. Bronze is building material. Popularly used in sculptures for excellent casting qualities. In architecture, it can be regularly found in hardware, doors, entrance, fountain, handrails, column padding, textural details such as plate, medallion, and panels. See some example. You can use this is a cast like you have on top of your door, but not in our country. This is in UK. But I remember when I went to Bali one day, when we went to Bali, this Ubud, there's a town called Ubud. So we were staying at one hotel, very eerie kind of hotel. The way I look at it, very full of plants, creeping on the walls, and very, shall I say, watery. And when the passage is watery, you can see dog crossover as you walk around the place. And sorry, frog was actually jumping here and there. So, and as when you enter my room, I got this kind of figure, this kind of thing on top of the door. Wow, that will surprise you. In Bali, it's different because the Hindu belief is something it is not in our culture. So, can be quite scary actually. We want to you're staying alone. Not like a row of hotel room in a high-rise building. No, high-rise hotel. It's just like a chalet, like they join to like semi-D and they got to walk through passage of, landscape or not. So quite eerie in a way, especially at night. So the door can be also made of brass. Of course, expensive door. Fountain sculpture here, made of brass. The one fountain near the Sultan Bersamad is made also brass. You can check the detail there. This is imported from this long time ago. I thought some of the still there. I'm not very sure whether the fountain is still there near the Taurus flag there. And then railing, yes, a brass railing, brass railing, but not commonly used in Malaysia, the most commonly used in Malaysia, basically on stainless steel, aluminium railing, cast iron, wrought iron, those kind of material for railing. And then the facade. This is facade, something like a wall facade, but I think it's going to be very expensive. It looks nice, something like copper finish, but it's made of brass. Medallion, even coin for that matter. Medal. Okay, lastly on solder. Okay, solder is fusible metal used to join together metal work pieces and having a melting point below that of the workpiece. It's an alloy of lead and tin, so lead to solder. Solder is used for electronic, plumbing, jewelry making, repair processes where metal parts cannot be effectively or safely welded. So look at some of these. They got to use, for example, in the computer chip here, computer board here, they use solder to join the parts. So basically, if we're talking about architecture, soldering or the pipe, you can use pipe, lithium pipe, copper pipe, also can use solder, can be soldered. So you know about welding, you know about soldering. Welding, you heard about welding, but brazing, maybe you have not about welding. What are the difference between these three? I just managed to capture some of this. Soldering is basically, it's what you see in the picture here, a small part, has no structural quality. It is like what they are the weakest joint of the three, soldering, not to bear the weight, generally used for make electrical contacts. Brazing, something like in between. They are stronger than soldering, but also weak than welding. It can be used to bear some load, but not too much of load. By using this metal filament here. But welding is the strongest of all. Strongest joint that can bear the load. Strength of welded joint can exceed the strength of base metal. We've been learning about this jointing technique. Welding is how the metal members have been welded together. As mentioned here, that the strength of the welded point joint, the welded point, is even stronger than the base metal, than the girder itself. For example, you're jointing girder of the beam and the column beam. universal panel. Then you join together. When you complete the jointing, even the jointing, the welding is even stronger than the girder. Yeah, that's what they mean here. So in architecture, what do you? I try to bring something that has to do with some decorative feature that where soldering is being used in architecture. Yeah, I put the effect of stained glass in most. So basically, stained glass are made by soldering the glass together. Yeah, that's why the stained glass is very expensive. At one time, I know that stained glass is expensive, but I got quite a. I mean, we have to do kind of client. I say, why not we do this? The top tower here put stained glass. And then you were trying to get some coat here and there, but it cannot be too expensive for a small portion. Yeah? This is stained glass, the effect of stained glass. Okay, this is how stained glass works. They cut, that's a process. We're not going to detail the process. No, they cut all the pieces together, they solder all the pieces together to form whatever pattern you want to create. That's geometric or nature, like organic, whatever. So this the process very long. So that for pieces of this half moon kind of glass on top of a window, very nicely designed, and it gives some very reflection of colors in the interiors, and it can be quite expensive. Here's some example. For example, look at the kind of environment you get when you have some when the light will shine on the stained glass, it gives you some colorful interiors in the moss. It's all about moss. Moss. Of course, in cold countries and bad countries, probably you can use this. You can bring light inside, but not in our country. But you got to protect the sun from entering. I mean, to at least reduce the heat gain inside. If not, unless you use air conditioning, that's different. This is another view. It can be quite, refreshing and colorful. The kind of pattern you can create, but not only moss, but this is found in early churches. Churches, yes, of course, there are a lot of figurative kind of elements there. I don't show it here. This is another view. Look at the reflection of light as the sunlight enters the room. You can use some colorful, even if you have carpet, so the colors still stand out. This is a kind of, we can create a lot of pattern. I mean, I'm talking about Islamic pattern in design by using this so-called stained glass. But again, we use, instead of stained glass, we call it colored glass. Colored glass can be framed. It can have normal frame, aluminum frame, timber frame, and just put pieces of colored glass together. You got black, you got green, yellow, red, orange, this kind of thing. So that's why you see most of the glass in the mosque. They use a lot of colored glass, not this so-called stained glass. Okay, I think we just refresh what we have discussed for this topic, type of metals. There are two types of metals, two main groups. Basically, one is ferrous. Ferrous is with iron content. Non-ferrous is without iron content. Ferrous is with magnetic pull, magnetic attracted to the material, and non-ferrous is without magnetic pull. Okay, basically, ferrous is consists of two: pure ferrous metal, alloy ferrous metal. So we are concerned more on the alloy ferrous metal, which involves steel here. Steel. So steel is the main focus of our syllabus for this semester. We'll be looking at this field. This is where the steel stay in terms of this composition of the material. The other one, non-ferrous, basically comprises of this pure without any other alloy. Of course, the pure means that they don't add, but they extract out some of the material to make it pure. Copper, aluminum, zinc, tin, and so on. And then the other ferrous, mercury basically is another liquid metal, which is not so much kita mention so much here because it's not so much used in the building. Then lastly is about non-ferrous alloy. Alloy. Ingat, alloy is a mix of two, a mixture of two materials. That's alloy. We say alloy is only mix 2, 3, or maybe more material. It depends on what kind of property you want to create for that kind of material. So some, the one of the sentence that I mentioned just now, they want steel grading also. There are about 3,500 type of steel. So it depends on combination of maybe carbon content and maybe some other material to add on as an alloy material. So basically, non-ferrous alloy comprises of three main ones. There's a lot, but I just choose this main three one only: brass, bronze, and solder, with a bit of a relationship to architectural building. and also for construction purposes. Okay, I think I will end up my needs about 2 hours, almost 2 hours. You have any question? I'm ready to answer your question. Oh, okay, any question? Hey guys, are you there?
Yes, I
Yes,
do.
Yes, sir.
Yeah. Okay, yes. Okay, faham tak? The most important thing, I must make sure that you understand what I'm talking here. You understand what I've been showing on the screen, faham eh? But the fact that, you know, as an architect, you have you know everything. They call it a master of trade. Sorry. What's the word again? Master of none. You know all trade but master of none. Maksudnya you know everything about building material, about construction technique. When it come a time that you want to search for it, you know where to find it. Yeah, that's one thing about architect. They don't keep in their mind so much, but when they know they come across it. When they want to find the detail, they know where to find it. That's about architect lah. So the material is just introduction to you. I hope if not 50%, 40%, 30%, at least you can get for 60, 70%. That's very good. You know, but this one I've upload in the goal. The first lecture already uploaded in the goal. There's nothing much there, but maybe today, tomorrow I will upload this in the goal, so you can still go back and refer. Refer to refresh. At least don't wait too long. Don't wait until probably after the 3 or 4 lectures. Once I've already upload, you relook at it, and then the knowledge of what I'm talking about still fresh in your mind, and then the knowledge can be absorbed and keep in your mind. Whenever it come across, and then you know where to find it. Whenever you need to use it, you know what to find it, where to find it, what to choose, those kind of thing. Yeah. Okay. Ada soalan lagi?
I have a question, sir. Can you hear me well now?
Tak dengar lah, kan hear. Macam very. Okay, I cuba stop sharing and then you can share dalam chat. Okay, ada stop sharing. You can share the chat there.
Yeah, can you hear me now?
Just a minute. Okay.
Okay. I wanted to ask about the buildings that use metal, like because metals conduct heat. You can't hear me?
Sorry, Heba. I really can hear you because it's so the voice distorted a bit and it's echo. Like there's an echo.
I switched to
Right.
my phone now. How is it?
There. This is clear.
Alright. I was asking for buildings that use metal. Metal conducts heat, so like the building of Frangary, how is it like? I wonder if I touch it, wouldn't like it be like hot from the sun or how?
You see the metal, not metal as skin that we imagine. There are a lot of layers in the wall, to protect the heat gain, to contain the
To
heat
absorb
inside.
the heat.
There's like composite layers inside, insulation, the waterproofing. That depend on the nature of the situation of the climate of that place. So not just a simple skin. Skin is just an add-on kind of thing.
I see.
And later on, I will show you some detail in the future lectures on cladding and frame. We show some detail how these are being fixed together, to become one composite material. What we see, we thought, but in climate like Malaysia, even in Dubai, it's very hot, isn't it? It can reach even 50 degrees Celsius, but of course they use metal too. But again, they have a lot of insulation inside it. Just like what I mentioned about zinc just now. You remember the zinc roof? Zinc roof is a single sheet metal that we see as what we see. That is the material. There's no insulation behind it or below it. So I mentioned to you just now, the heat gain is so high during hot time, during noon, but the heat loss, is very fast once the sun is already, maybe up to 5 or 7 o'clock, then and 6 o'clock, then it's very cold already. So it doesn't retain heat there. Unlike other material, like when it says there's a bit density, has some mass inside it. For example, concrete, concrete wall, brick wall. Then you can retain heat. Then the heat will be released at night. You can feel the wall is very warm. But our country we don't need that. But I mean in UK, Europe, maybe we need that wall to be warm. But UK the construction is different because they got cavity wall to stop from condensation. That will different. It depends on the local climate.
Yeah.
We'll come to the detail later on, inshallah.
Inshallah.
Okay, guys. Okay, Haji, I would like to ask. It's a lot of type of metal. Okay, you would like to build something. How we decide the material that you want to use for the building? We follow our client or authority or okay, that's a good question. Basically, we got a right to choose. But of course, they depend on. They are not a criteria for the selection. First, of course, we're talking about cost. The first thing the client will see how much it costs. First, the second thing about durability, whether it is can it stand the weather. How about maintenance maintenance aspect, How about construction technique? Is it practical or not practical? How about whatever support system that we need to choose the material? That's why that sometimes they go for an optimum kind of material where it is safe in terms of costing, easily maintained, and it serves a function as a wall to protect the heat and to protect whatever the accessory from the inside. This for the room, for the wall, for the roof. If I'm not mistaken, I think Felda Auditorium near Felda Auditorium near Jalan Geni Road, Jalan Semarak there. I think they use titanium roof, that one. Maybe Felda got money, but they want the free maintenance maybe, because in our weather, roof stain, it may last in terms of the durability of the material, but if you design a roof at inclination, a slanting roof, it stain more than a flat roof or a low, shall I say, radiant roof. You can, because in our weather, especially in Malaysia, there are so much of dust in the air. This dust is floating in the air. If you are glass roof, slanting roof, and then you have some kind of electromagnetic kind of pull, the dust will rest on, will stop and land on the surface of the roof, and then the rain comes. The rain comes, and if it is a downpour, like wash everything good, but sometimes it drizzle, so the rain just drop a few, and I mean, the stain is still there. The stain become hardened, and then more dust will be collect, and then the rain will again doesn't wash all together. They become stain. So a lot of stain. It come to a stand to one stage, whereby I think I've been looking at this. If I photograph, I can show you later on. Shah Alam Municipal Council, the Shah Alam Municipal Council, the Bandar City Hall of Shah Alam building. Their roof made of tiles, but too much of stain until there's some chemical reaction, the tile peel off, come up from the surface of the roof, then it fall on the ground. They can be costly, can drop on people's head, maybe you can injure even with small tile, because of the weight and the height, maybe can injure. End of the day, you got to spend another 25 million to just wrap the building with aluminum cladding. This is the problem with the choice of material, and again the way you design the thing. Kalau yang, for example, like for roof tile, gloss roof tile is more expensive than matte roof tile. Clay tile is more expensive than concrete tile. Because clay tile, it can reflect, I mean, it doesn't absorb so much heat. Concrete tile absorb heat, then heat transfer into the room, then become very hot. But gloss means that it's very shiny, imported from maybe like Istana Selangor here, Datuk Tengku Sulaiman house made of a glass roof, and it is maintenance free. There is no stain at all. Even library of Shah Alam Library and part of the City Hall Shah Alam, the roof also made of gloss roof. The gloss, the free maintenance, is not dirty. Most of this roof is made of clay, even it gets stained very fast. Clear roof. If you happen to drive along the Jalan Tun Razak facing the American Embassy, They make of clay roof. Initially, when it was installed, it was very nice looking clay color. But after a while, because the rain and sun, now it become very much stained. Just like our colonial houses, very, very much stained. But the property of the material is still good. It can, okay, I think the cost is the main factor here. Unless you have the money, then you forget about the cost, then we can talk about the quality of the product. Okay? The higher the cost, or the higher the architect's fee. Some people want to do that. Any more question? Okay, thank you. All right, you're welcome. Welcome. Okay, now it's coming to Asa. Tell what we stop here unless you have more questions. Yeah? Okay, is Haji, is all steel material need maintenance if you want to use? Not that all. You need maintenance for mild steel. Okay, that is the most difficult material to maintain. Okay, unless when you start constructing by mild steel, you have already included your coating material. That means a special paint to coat. Even like ship, for example, they are made of my steel, but they are in the sea. Not because of the coating, then the steel can retain, doesn't rust at all. So the coating material can be expensive, but it can be done, no problem. If it is exposed steel, then you have this kind of problem. You know why that Malaysia doesn't have so much of this exoskeletal kind of structure? Exoskeletal means that exposed frame. Exposed frame like you see in those building having a frame outside and the finishes inside. I think I showed you one building that the first lecture, the yellow building having this mass cable, exposed frame. We don't have that because of weather. Weather, and again, all the team members will collect a lot of rust, and a lot of dust, and then this dust will collect there and then become rust. If you happen to go to Stadium Shah Alam, maybe you have not been there, but I've seen it when it start construction. Until now, it is in a dilapidated stage where the roof is blown away because of the small pieces of polycarbonate. Over the years, it get rotten, and it's just very easily blown. Any small wind, not thunderstorm, so the roof can be blown away. So it's not just the moment. And they use this space frame. I mean, we'll talk about space frame during our future lectures. And this space frame is getting deteriorated too because they're exposed to rain. Later on, I think they have to spend a lot of money to maintain this space frame. So the choice of maintenance is one of the key factors to actually decide on materials. Some of the material, if it is protected, it's not too bad. Under the roof, protected, then it's okay. If it's not protected, you want to have some nice architectural element exposed outside with cable and mast and whatever. And at the end of the day, that all the joints start to turn yellowish, and then greenish, or not greenish, brownish. So you see that the rust start to come in. Then there'll be a lot of problem. Unless you use the non-corrosion material, which is stainless steel, aluminium, and other thing that we mentioned just now. Itu boleh, stainless steel, no problem. Stainless steel can be used for outside. For small structure, can. For big structure, may not be viable because too expensive. But for building like Petronas Tower, Twin Tower, I do not know that it was made of stainless steel until somebody told me, the architect who was involved in the project. Wow, I said, the government must be paying through their nose for this huge areas of stainless steel covering the two what they call these towers. But again, they want the so-called the building to be shining at night and shining all the time. So that's the best material. And again, the maintenance is probably in long term is cheaper. If you're talking about the building's been painted, even tile for that matter, the tile could probably peel off after 5 years. You start to drop. So if they painted, I tell you, in our kind of weather, unless you use special paint like DuPont coating, DuPont, DuPont coating, then probably it's safe. Use normal paint, weatherproof paint as they call it. No, probably after 3 or 4 years you got to repaint. That is the things that actually cost you a lot of money for maintenance purposes. That's why architect, when they are doing design, they have to think of this maintenance, the post-occupancy kind of problem, which include maintenance. If you have a chance to see my building I have designed, most of the building, I don't have to hire a crane to actually change the roof. I don't have to hire a crane to clean the roof. Actually, all the building can be accessed from a door, staircase, and step until it goes to the roof. So all my building, you can reach the end of the roof. So this is one of the criteria in doing my design, so that it could reduce some cost actually in doing maintenance. Because most of the building, they want to do something in the roof, they got to hire a crane, block the road, and then do things up there. So that is not in my building. All right. Maybe we can add more later on when we go through other what you call this topics in our future lectures, inshallah. Okay, guys, good. It is, shall I say, a good start. That I see that some of you come up with some question, which I think in future we need more question. If you cannot need, just put a chat here, then we can answer, we can share together. All right, guys. Inshallah.
Yes.
Okay, inshallah. I will stop here. Inshallah, and then kita akan sambung balik usual time next week. We keep it at 2 o'clock. And then try to come in a bit early kalau boleh. If not, we have to actually wait for at least 15 minutes. So wait 15 minutes kat situ. Alright guys, so kita... Yes.
Boleh tak nanti Haji hantar gambar Haji kat saya, sebab saya AJK Multimedia nak letak dalam.
Okay. Oh yeah, I wanted to show something. I want to send you something about this class photo. I send to your WhatsApp sekarang.
Alright.
You do this for everybody lah, for